So, good morning, good afternoon, everyone. On behalf of BatteryPlat, the Spanish technology and innovation platform for energy storage, it is my pleasure to welcome you to today's webinar, Connecting Ecosystems, Spain-China Collaboration Opportunities in Energy Storage. First of all, I would like to sincerely thank our distinguished partners and speakers for joining us today, the China Energy Storage Alliance, LONGI, the Chinese Academy of Science through the Institute of Engineering Thermophysics, and IEPIBAL. We greatly appreciate your willingness to share your expertise and perspectives with the Spanish energy community. BatteryPlat was created to foster collaboration across the Spanish energy storage ecosystem. Today, our platform brings together 128 members, including universities, research organizations, technology centers, large companies, SMEs, and startups. Despite our name, BatteryPlat is not solely focused on batteries. We represent the full range of energy storage technologies, from electrochemical storage to thermal, mechanical, and hydrogen-based solutions, reflecting the diversity and growing importance of storage for the energy transition. We strongly believe that international cooperation is essential to accelerate innovation, support industrial development, and facilitate the deployment of sustainable energy solutions worldwide. This is why we are particularly pleased to organize today's exchange with our Chinese counterparts and partners. The purpose of today's webinar is not only to exchange information about our respective markets and technological developments, but also to identify areas where cooperation can create value for both sides. This may include research and innovation projects, technology development, market intelligence, industrial partnerships, business models, and the exchange of best practices. I am particularly pleased to see the diversity of participants joining us today from industry, academia, research centers, and public institutions. This diversity is one of the strengths of the energy storage sector and an important foundation for future collaboration between Spain and China. I hope today's discussion will provide valuable insights, generate new connections, and open the door to future cooperative initiatives between organizations and ecosystems. I wish you a productive and inspiring webinar. Now, let us begin with the first presentation.
Thank you, Luis. So this first presentation is about R&D and energy storage in Spain. Let me start sharing the screen. Okay. Okay, so you are seeing the screen, right?
Yes, we are.
Okay. So this presentation from BatteryPlat is not just a collection of data. It is a layered approach based on 3 studies to help decision for BatteryPlat in Spanish actors. This 3-layered approach is based on 3 studies: a technology maturity study, a technology intelligence study, and a capability map. The objective of our of this study, of this research, is to understand where technology stand, where innovation is being projected, and where Spanish capabilities are located. BatteryPlat is part of the Spanish energy storage strategy, and this strategy takes into account grid flexibility, industrial opportunity, and innovation agenda. And the BatteryPlat role is to connect public strategy with technology evidence and ecosystem capabilities. The 3 studies that have been used for this presentation are, first of all, a taxonomy study, then a technology watch and competitive intelligence study, and finally, an internal capability map. The idea is to combine the information and the data of these 3 of these three studies to offer an overview of global and Spanish energy storage sector, and also how the BatteryPlat members are located in this context. The first one is the taxonomy study. This study wants to offer a transparent and pragmatic method to compare technology maturity. This does not replace detailed technology assessment, but it makes comparison clearer and less dependent on a single subjective maturity level. The indicators we have used in this study are 5 indicators, such as total installed capacity, total installed power, number of installations, age of installations, and the annual increase in installed capacity. The maturity is offered as a combined function of these 5 indicators. For the study, we have used data from the Department of Energy of the United States and from the European Storage Technologies and Facilities database. Of course, the result of this study depends on the availability of sources and information about installed capacity all around the world. In this assessment, we have identified 5 different electrochemical energy storage families: electrochemical, electromagnetic, mechanical, thermal, and chemical. This shows the broad approach and the broad scope that we have here in BatteryPlat, since we believe that no single technology fits every storage need. So we need a combination of several technologies. Here you can see one graphic of this study that compares for different energy storage families: mechanical, chemical, thermal, and electrochemical. As you can see, the farther the segment, the figure is from the center, the more mature is the technology. But it is not just an overview of the maturity, it also allows comparing technologies across several indicators. Here we focus on electrochemical energy storage, that as we can see later here right now represents the hotspot for innovation. You can see in this graphic a comparison between lithium-ion batteries, nickel batteries, sodium batteries, zinc batteries. Of course, lithium-ion batteries represents the most mature, but what is interesting and critical is that there are other R&D&I topics, including safety, degradation, thermal management, BMS, integration, and recycling, that offer a great opportunity for innovation. The second study, as I was saying, is the Technology Watch and Competitive Intelligence study. In this study, we have analyzed almost 8,000 patent documents. We have detected almost 600 companies in a time range between 2019 and 2023. We're going to publish an update of this study in the next months. And the objective was to identify active patent holders, compare global activity, and then understand where Spain stands. In this graphic, we can see that in the latest year, the innovation pressure on energy storage has been increasing significantly. This justifies our work and our technological watch. In fact, beside these studies, we publish every 2 months some assessments of the latest patents, market trends. They are available for free on our website. Here you can see that most of the patents, more than 60% of them, have been detected in the electrochemical field, followed by electromagnetic, mechanical, thermal, and chemical energy storage. Although electrochemical is clearly the hotspot for innovation, there is still a lot of opportunities in the other technological families. Since, as I said before, electrochemical storage is the main field where innovation is focusing right now, we are going to focus in the next slides on this family, since we don't have much time to focus on each one of them. And here in this graphic, you can see where most of this innovation is focused geographically. Clearly, Asia dominates the top of the patent ranking, mostly through CATL and LG. We can see also there are some European actors such as Bosch, BMW, Volvo, Valeo, and other Spanish actors like General Electric, Siemens Gamesa, SEAT, Ferrovial. So in this context, how do we place Spain? In Spain, have been detected 185 companies across these 5 families, most of them in the electrochemical storage, followed by thermal, chemical, mechanical, and electromagnetic. Again, this graphic and the previous one are not a market share assessment. They're more based on patents and actors. So if we focus on the value chain in Spain, we can see that most of the actors are located in system integration, main system manufacturing, component manufacturing, operation and maintenance. This offers important information to understand where cooperation with Spanish partners can be established. It also allows us to understand where our value chain needs to be strengthened and where we can look for cooperation with other members from Europe and other countries. So how are these companies distributed in Spain? Most of them are located in Madrid, followed by Catalonia, Andalusia, Valencia. Our role as innovation platform is to connect regional capacities with technology families and value chain needs. The third study, as I was saying, is an internal capability map where we try to understand how our members are located in the value chain and in our technology tree to orient collaboration, visibility, and then updates our member capability profiles. As you can see, most of our members, 44%, are companies, followed by research center, university, technology center, and associations. Here we can see how they are distributed along the value chain, the technology families, and the electrochemical subtype. About the value chain, most of them are system integrators, followed by consulting services, component manufacturing, raw material production. So we can understand, we can extract the same conclusion that we did with the Spanish value chain. We can understand from this graphic where our strengths and where collaboration can be offered for our members, and also which are the steps of the value chain where we can strengthen our collaboration. So the distribution across the family technology, most of them are focused on electrochemical, followed by chemical, thermal, mechanical, and electrical. And if we focus on technology, most of them work in the lithium-ion sector, followed by flow batteries, beyond lithium-ion, supercapacitors, sodium, and then other batteries. To sum up what we've seen so far, a portfolio view is essential, since energy storage should be read as a complementary technology approach. Electrochemical storage right now represents the innovation hotspot of energy storage. The Spanish value chain shows strength in integration, operation, and maintenance. And the role of BatteryPlat is to convert this mapping into collaboration and allowing matchmaking by region, the Spanish region, but also worldwide region. So the next step would be to use these findings to prioritize thematic workshops, regional outreach, and R&D matchmaking actions. So thank you. This was my last slide. We can go ahead with the next presentation. Gemma Sabala from IEPIBAL.
Hello, can you hear me, Francesco?
Yes, Gemma.
Okay,
yes.
Perfect. Thank you very much, and thank you for having the opportunity to represent the Viva. Let me try to share my screen and let me know if you can see it properly. Can you see it?
Yes, we are seeing the PowerPoint. Oh yes, right now we can see the full screen. Gemma Sabala is market advisor at IEPIBAL, the Energy Storage Association of Spain, and managing director at Alantra. Gemma?
Yeah, thank you very much, Francesco. So basically, the purpose of this presentation that we are going to deliver is to provide an overview of what is the current context of batteries in the Spanish market. As you might know, the Spanish market is quite a nascent one. So up to now, the presence of battery storage systems in the market was almost inexistent, and what we are seeing is that there is strong appetite and increasing appetite for the development of this technology. The outline for this presentation, first, we're going to touch upon the current development status of batteries, so where we are standing right now and what is the expectation of development of batteries in the near future. After, to provide an overview on how we see the business model and what is the market outlook and the potential revenues that this technology can tap right now in the Spanish system, and what are the key drivers for generating a profitable business case for batteries in the Spanish system. So as I was mentioning, the status of battery development right now in terms of operational projects and projects under development is quite nascent. So as you can see here in the top part of the slide, the current installed capacity in operation in the system barely reaches 250 megawatt, most of it belonging to the traditional utilities, and most of it coming from hybrid projects. So as you can see, there is a lot of room for the development of batteries in the Spanish system. As we were discussing with Francesco before, there are other sources of storage in the system. It's not that we don't have any storage capacity as of today, but most of the storage capacity that is present in the Spanish market comes from pumping hydro. We already have a significant capacity installed from pumping hydro facilities, but the reality is that right now we are seeing that electrochemical solutions are becoming more and more competitive, and there is a strong interest for development of batteries. And actually, the current context of prices in the system, the penetration of solar PV in the Spanish market is something that is providing for quite an interesting business case for batteries, and we will see later how this perspective for potential revenues will evolve. Talking about the appetite or the interest for this technology, what we were mentioning before, apart from the 250 megawatts of batteries in operation, what we have is more than 35 gigawatts of battery projects under different stages of development. So in Spain, the first stage of development is to secure the access and connection permit to the grid. And for access and connection permit, right now we have around 13 gigawatts of hybrid projects already with access and connection permit secured. And when it comes to standalone, we are around 10 gigawatts of standalone assets already with access and connection permit. And along the permitting process, after you need to secure the relevant permits in order to be in operation, and there is where we are seeing a lot of projects that are progressing in the pipeline. Our view is that probably by 2030, we will see in the system an installed capacity from batteries in the range of 6 gigawatts, 6.5 gigawatts in the system. So still a lot of room for further development. And this is well below the current targets that the government has. We have the National Energy and Climate Plan in Spain, in which basically the target for battery storage system amounts to around 12 gigawatts, but the reality is that this plan probably will not be achieved in the rest of the aspects that were incorporated, and probably we will be having around 6.5 gigawatts of battery capacity by 2030. As I said, most of the bulk of the projects that right now are progressing in the development process are hybrid projects. So as we were mentioning, in Spain, we have a lot of PV capacity in the system, and there is a natural hedge or a natural complementarity between the generation of a PV asset and the operation of a battery in the market. And this is why we are seeing more and more hybrid projects that are progressing in the permitting process in order to secure this natural hedge and in order to facilitate a more efficient integration of the excess renewable that we are having in the central hours of the day. Just to give some figures on the PV capacity, which is something that is a key driver for providing an interesting business case for batteries. The reality is that right now we have more than 50 gigawatts of PV capacity in the system, despite having already a big cannibalization of capture prices for solar. Last year, capture price for solar was in the range of 30 euros per megawatt hour, and probably this year we will be closing the year with a capture price for solar below 25 euros per megawatt hour, and this is basically hindering the profitability of these assets. It's true that we are seeing a strong inertia in the installation of PV, but we are expecting to see a significant slowdown going forward because of the lack of ability to integrate this additional PV capacity, the lack of flexibility that we are still having in the system, and also the lack of additional demand that hopefully will be entering into the market in the coming years. So taking an overview on the business case for batteries, the market outlook, and the revenue stacking. What it is worth highlighting in Spain is that since 2020, we are seeing that every single year the day-ahead prices in the central hours of the day is decreasing substantially, and on the contrary, we are seeing that peak prices in the system are increasing recurrently every single year. So basically, the gap between the low prices and the high prices in the system is something that is increasing over time, and this is something that is somehow showcasing an interesting business case for doing arbitrage in the system. On top of that, because of the high renewable capacity that we have in the system right now, the cost of the balancing services, and particularly the AFRR reserve band, which is basically the secondary band, is something that is constantly growing, and we are seeing that the system cost of Spain is booming, and this is a strong opportunity for batteries to tap into those revenues and eventually have an interesting business case as they compete against the CCGTs and the hydro plants for capturing the system cost that we have because of the huge capacity from renewables that is entering into the system. Talking about the zero prices or very low prices in the central hours of the day, we are seeing that on a steady basis every single year we are seeing that the amount of hours with prices below 4 euros per megawatt hour is increasing. Basically, this year we will close the year with around 1,200 hours with reference price below 4 euros per megawatt hour. So the opportunity to charge a battery or a flexibility system in the central hours of the day and take advantage of the difference between peak and off-peak prices is something that from our perspective is structural in the system and is something that will remain for quite some time. Later on, we are going to provide our view on how this spread is going to evolve and what is the actual risk of reduction in these arbitrage opportunities in the system. What we were mentioning, capture prices has been decreasing on a steady state since 2020. So in 2024, the capture price was around 40 euros per megawatt hour. Last year, it barely reaches 35 euros, and our view is that this year probably it will be in the range of 25 euros per megawatt hour. And what we are seeing is that there is still an inertia of installing additional PV capacity, which probably will lead to finding in the coming years a lower capture rate for PV systems, and this is something that is providing for an interesting opportunity for battery storage system to capture this difference between low prices and high prices. What is the expectation in terms of, I will jump directly into our expectation of the capture prices and the different scenarios. So basically we are seeing that up to 2027, 2028, probably we will keep seeing capture prices decreasing over time. Basically what we are seeing is that we have this inertia of adding additional capacity of PV system while the demand increase or the flexibility is not accompanying this installation of additional PV capacity. So we are constantly increasing the excess renewable that we have in the central hours of the day, while we are not able to accommodate or integrate this renewable efficiently. Our view is that probably from 2028 onwards, there will be a number of factors coexisting that hopefully will provide for a stabilization of this capture price depletion, and hopefully will allow for a more efficient integration of solar PV capacity. Basically, what we are seeing is that from 2028 onwards, the PV capacity slows down. The commissioning of additional PV capacity decreases substantially. There is already an increase in the demand coming from electric vehicles, digital infrastructure, and some projects coming from green hydrogen. And we are also seeing that we will have an additional interconnection between Spain and France that will allow for capacity to export the excess PV that we have in the system, and hopefully this will provide for a more balanced development of additional capacity vis-a-vis the increase in the demand and flexibility. On the contrary, the decrease in capture prices provides for an increase in the average spread in the system. So last year we closed the year with an average spread of around 100 euros per megawatt hour. Basically, that means that every single year the most expensive hour in the market and the cheapest hour in the market had a difference of 100 euros per megawatt hour. Of course, when it comes to 2 or 4 hours, there is a reduction in this average spread that can be captured, but the reality is that according to our projections, because of this structural difference in the peak and off-peak prices in the market that we are expecting to see, probably this difference between cheap prices and expensive prices in the market is something that will last for quite some time. So our view is that up to 2035 or 2036, we will not see a relevant reduction in the arbitrage opportunities that you can capture and the spread that you can capture in the day-ahead market. On top of that, what we mentioned before is that the total system cost is something that is increasing because of the additional renewable capacity that we have in the system. So we are seeing that the cost of technical constraints and balancing services is going above 6 billion euros. And the reality is that this is providing a huge opportunity for batteries to capture those revenues. So the balancing services that we have here in Spain is the AFRR market and the MFRR market, which are the balancing services that are remunerated here in Spain. And on top of that, we have the technical constraints market, which is amounting to more than 5 billion euros. So all those markets are markets that are accessible for batteries. As of today, we barely have these 250 megawatts of batteries. So the reality is that there is no significant competition against the CCGTs and hydro, which are the traditional providers of these services. But our expectation is that going forward, as we have more capacity installed in the system, the first batteries that are going to be entering into operation probably will benefit from a significant upside of operating in these markets. Of course, the risk of these markets is, on the contrary of the day-ahead market and the structural spread that we see in the system, these markets are having much lower liquidity in volumes, and therefore our expectation is that once the capacity in operation in the system reaches a certain threshold, probably the cannibalization of these revenues will be quite material. Talking about the revenue stacking options that we see in Spain, as we were mentioning before, so we have the day-ahead market arbitrage, which basically is to buy cheap and sell in the peak prices. As I mentioned before, last year we have an average spread above 100 euros per megawatt hour. Probably this year we will see similar references, and that means that the potential revenue that a 4 hours battery could be capturing in this market is above 100,000 euros per megawatt per year. On top of that, we have the secondary ban operation, which, as I mentioned before, there is a huge opportunity to tap interesting revenues in this market. This is a market that is split between availability and activation. So it's a market in which you can offer your capacity up and down, and after the system operator will activate you depending on the system needs. And basically in this market, what we see right now is that a battery with 4 hours storage capacity could be capturing above 300,000 euros per megawatt per year. And after we have the tertiary, the MFRR market, which is an additional arbitrage opportunity depending on the activation of the tertiary reserve needs. Basically, when it comes to the revenue stacking composition, what we see is that probably during the first years of operation, batteries that are entering into the market will predominantly allocate their capacity to the balancing services, so to the AFRR market. But on a steady state, once these markets are cannibalized, the main source of revenue will come from arbitrage opportunity. And this is what we are showing right now. The reality is that the market is already there. So if we were to have a battery in operation in the last 4 or 5 years, a 4 hours battery could have captured around 300,000 euros per megawatt. So it's something that is already there. our expectation is that as batteries are entering into the system, once we have a significant amount of batteries in operation, the potential upside that could be captured from the AFRR market is something that will be cannibalized rapidly, because as I mentioned before, the size of this market is around 2 gigawatts, and even though it might increase a little bit, once we have an installed capacity from batteries above 5 gigawatts or 6 gigawatts, which is what we are expecting to see by 2030, probably the cannibalization in this market could be quite material. But what we see here, what we mentioned before, is that there is a structural opportunity to capture arbitrage income, which is the bottom column that we see here in this graph. And this is something that will last for quite some time, because we have this structural difference between the peak and off-peak prices in the system. And what are the key value drivers of this revenue stacking and business case? What we mentioned before, the opportunities in the day-ahead market. So the renewable energy surplus versus the thermal gap that we still have in the evening time is something that is quite material. So we see that even if we are having 50 gigawatts of additional demand capacity or additional generation capacity in the peak of the evening, we still have some opportunities to capture this arbitrage gap, so this spread. What we see is that in the central hours of the day, where we have very low prices, even with 15 gigawatts of additional demand, prices will remain very low. And also during the evening time, because of the lack of mass run generation for those hours, so we don't have that much wind capacity. There's a lot of bottlenecks to develop additional wind capacity in the system, and there are a lot of hours in which we rely on CCGTs or hydro plants operating at the marginal cost of the CCGTs during the evening time that probably will lead us to estimate a huge opportunity to capture arbitrage opportunities with batteries going forward. Talking about the opportunities in the balancing services, what we mentioned before. So the cost of balancing services and technical constraints is going above 5 billion euros, and this is a huge opportunity for batteries to take advantage of these markets and eventually to make them collapse at the benefit or benefiting the consumers, because in the end, if we are able to lower this cost, the reality is that we will have electricity bills that are more competitive, and that will mean that probably the system cost will decrease substantially. Of course, this will be at the cost of having lower revenues for batteries, but it's something that we have seen in other markets. That is what batteries can provide. Batteries can benefit from these price signals, and of course, since these markets are very low in volume, probably when they collapse, batteries will need to shift their operation towards other markets that are more liquid, like the arbitrage opportunities that we mentioned before. There are also opportunities to do financial trading and to operate in the intraday markets, and those opportunities, again, our view is that given the liquidity that these markets are having, probably will cannibalize rapidly. So on a steady state, our view is that the operation will be mainly driven by day-ahead opportunities. Financial trading, again, a market that could amount to 500 million euros potential with perfect foresight ability for batteries. And one thing that is also worth mentioning is that we are ongoing a number of regulatory updates that are happening in the Spanish market. So even though we have made a lot of progress when it comes to the market rules and the regulation that is affecting batteries, the reality is that not all is already in place. So we are now in the process of discussing the flexible demand permits for batteries, because in the end, batteries will be having a flexible demand approach, meaning that if the system is suffering any sort of congestion, the batteries will be the one that will be first not allowed to consume from the grid if you are having a demand permit. So there are a number of ongoing changes that is worth evaluating in detail, because eventually, depending on where the battery is located, you might face some limitations if you are willing to charge from the grid your battery, and eventually this might have an impact on the revenue stacking model that you are aiming at capturing in the market. Depending on where you are located and depending on the state situation, right now we are discussing several frameworks for the flexible demand permits. I will not enter into all details, but it's worth evaluating in detail what the implications of the flexible demand permits will be. Another thing that is also worth mentioning is that we are seeing more and more interest on longer duration storage. So up to now, the main configurations that sponsors and investors were assessing in the Spanish market were around 2 hours or 4 hours storage duration. What we are seeing is that on the long term, given the main operation and given the arbitrage operation that batteries will be having in the system, depending on the evolution of capex of the energy component and power component of the batteries, eventually solutions with 5-6 hours could make sense in the Spanish system, because we are having a significant difference between the central hours of the day having low prices. These central hours of the day could last around 6 hours or 7 hours with very low prices. And as we mentioned before, the thermal gap that we are having still in the evening is amounting to around 8-9 hours. So probably this longer duration storage is something that would make sense in the long term, and it's something that there are some sponsors already evaluating. And this will depend, of course, on how capex are going to be evolving, and depending on whether capex is driven by the energy component or the capacity component, the optimal solution would shift from longer or shorter duration of storage. Another thing that is also probably will give a lot of visibility to the development of batteries, and this right now in the discussion, is the approval of the capacity market. This is the latest update that we have. We are expecting to have the final order and the final resolution because it has been already approved by the European Commission, and we are expecting to have the first capacity auction probably happening after summer. And this is something that will give additional visibility to sponsors to have some baseline revenue, contracted revenue, that will facilitate the financing of these projects, which is probably one of the main bottlenecks that we have right now in the system. One last point, only to mention the interest of hybridization in certain locations. We are suffering a lot of curtailment in certain areas because of the PV capacity that is entering into operation and the lack of system reinforcement that are ongoing from the system operator, from the EECAS. So particularly the area of Extremadura and Andalusia is suffering significant curtailment, and probably it's something that is attracting the interest from sponsors to incorporate battery to their projects in order to soften the impact of this curtailment in the revenues that their PV assets are capturing in the system. And that's all I have. Happy to address any questions or comment that might appear after this presentation, and thank you very much for the time.
Thank you, Gemma, for your presentation. So the next speaker will be Feng Yue, Deputy Secretary General of China Energy Storage Alliance, who's going to talk about value, revenue, and carbon assessment of large-scale energy storage in China.
Hello, Francisco. Can you hear us?
Yes.
Okay, we're gonna share our screen now, so that our Deputy Secretary General Ms. Yu Peng could share about the energy storage market in China. So this 1 second. 你用你的那个麦克风吗？我用的是你的。 Okay, here. Can you see our screen now?
Not yet.
Okay, 1 second. So Francisco, it seems our device has some problem. Could you share the file for us?
No problem.
Yeah, really appreciate your help.
Okay.
Okay, yeah, I can see this.
This is the right.
Thank
this
you.
Is the correct.
Yeah. Thank you very much.
No problem.
Good afternoon, everyone. My name is Yue Feng, Deputy
Secretary General of China Energy Storage Alliance, also known as CNESA. Very sorry for the screen sharing problem. And it's my great pleasure to join today's webinar. Thank you all for participating in this event. This event is co-organized by us and our distinguished Spanish partner, BatteryPlat. Let me introduce about CNESA first. CNESA is China's first national third-party organization dedicated to promoting the development of energy storage industry and supporting energy storage policy. Over the past 16 years, we have contributed to the industry's growth through conferences and events, policy research, standards development, market analysis, and international cooperation. I hope today's presentation will provide useful insights into China's energy storage market, especially for our partners from Spain. Next slide, please. In the next few minutes, I would like to share three things. First, why energy storage has become increasingly important in China's energy transition. Second, the latest development in China's energy storage development. And third, our outlook for future trends and opportunity. Next, please. In recent years, China has seen very rapid growth in renewable energy deployment. This rapid growth has been strongly driven by China's dual carbon goals, peaking carbon emission before 2030 and achieving carbon neutrality before 2060. As a result, wind and solar deployment has expanded rapidly since 2020. The share of wind and solar capacity in China's power system increased from 24% in 2020 to nearly 48% in 2025. At the same time, the share of the renewable electricity generation more than doubled, rising from nearly 10% to 22%. Next, please. Next page. Yeah. However, renewable energy is variable by nature. As more renewable energy connects to the grid, new challenges emerge. The power system needs more flexibility resources to manage this variability and maintain reliability. However, few flexibility resources can expand rapidly as renewable energy in China. The flexibility potential of coal-fired power plants is becoming increasingly limited after years of retrofitting. At the same time, pumped hydro storage takes a long time to build, often more than 8 years, and also is constrained by the geography. Also, gas-fired power plant can certainly provide flexibility, but fuel costs remain high in China. Demand response and VPP has great potential, but it's still at the very early stage in China now. As a result, energy storage has expanded rapidly since 2020, driven by falling costs and shorter construction cycles. Today, energy storage is being deployed across the generation side, grid side, and the customer side. Next, please. Let me move to the China's market deployment. Next. By the end of 2025, China's total installed storage capacity existed 200 gigawatts already. This includes the pumped hydro, lithium-ion, compressed air, thermal storage, and other technologies. New energy storage, which refers to all storage technologies I just mentioned, except the pumped hydro, the total capacity of new energy storage reached to nearly 145 gigawatts. A major milestone was reached last year as well. For the first time, pumped hydro accounted for less than 1/3 of China's total installed storage capacity, compared with around 90% just 5 years ago. That means battery storage has now become the main driver of the market growth. Next, please. In 2025 alone, China added more than 66 gigawatts of new energy storage. This is comparable to the total pumped hydro capacity built over previous decades. This remarkable growth has been closely linked to the rapid expansion of renewable energy. In 2025, China added nearly 120 gigawatts of wind power and more than 310 gigawatts of solar power, both reaching record highs. Next, please. Today, storage has become a flexible asset for renewable integration. In China, renewable energy projects equipped with storage generally move through the grid connection process faster than those without storage. We can also see this trend in the numbers. The storage to wind and solar ratio increased from less than 1% in 2020 to nearly 80% in 2025. The message is very clear in China. Storage is no longer optional. It's becoming essential. Next, please. Next. Thank you. The market structure is also evolving in China. Utilities remain the major investors in grid-scale projects, but private capital is increasing quickly, especially in standalone storage area. This reflects growing confidence in the commercial value of the standalone storage. Next, please. Across the industry chain, we see strong participation from system integrators, battery manufacturers, and power conversion system suppliers, and also other manufacturers from the industry chain. Each year, CNESA publishes industry rankings based on the market data. These charts shown here, and on the next page highlights the top 10 companies in several key segments of China's energy storage industry in 2025. Next. These rankings reflect a highly active and increasingly competitive market. Competition is accelerating innovation in technology and also improving product performance and driving down the cost of the products. Next, please. One of the biggest changes is the application structure. Around 2020, most projects were on the customer side, mainly to reduce electricity power consumption cost. Today, standalone grid-side storage has become the dominant application, accounting for nearly 60% of the total installed capacity. We can also see the figure from the chart on this page. Next, please. This shift has been strongly supported by China's ongoing electricity market reform. China is building a multi-layer electricity market, including mid and long-term market, sports market, and ancillary services markets. Market mechanisms are also emerging in several. Capacity mechanisms are also emerging in several provinces. Today, energy storage can participate as an independent market player and stack multiple revenue streams from different specific markets. Next, please. There are three main revenue sources for standalone energy storage. The first is energy upcharge, capturing value from electricity price differences across spot and medium to long-term electricity market. Second, ancillary services such as frequency regulation. Compensation is typically linked to the response speed, response duration, and performance accuracy. Third, capacity payment, which recognize the value of storage in ensuring power system reliability. Several provinces have introduced duration-based capacity compensation mechanisms for standalone energy storage. The design is based on the duration of local evening peak demand period, and also the compensation levels are benchmarked against coal-fired power plants, which also considering each province's power supply demand balance. For example, if a province's evening peak typically lasts 6 hours, then a 6-hour storage system is considered to provide its full capacity value. Overall storage is moving from a single revenue model to multiple revenue streams in China. This significantly improves the project bankability at current stage. Next, please. New applications are also emerging beyond the grid. Two key areas are zero carbon industrial parks and renewable direct supply projects. China is also strengthening renewable electricity consumption requirements for sectors like steel, cement, and data centers. For example, new data centers are targeting up to 80% renewable electricity use. At the same time, China has launched 52 zero carbon industrial park pilot projects. These initiatives are creating strong demand for the combination of renewable energy and energy storage. Next, please. In parallel, carbon counting is becoming increasingly important. CNESA and its partners have developed a carbon footprint standard for battery storage system. The goal is to establish a unified life cycle carbon accounting methodology. This will improve transparency between different projects and also support international comparability. Next, please. Next. Looking ahead, two trends stand out in China's storage market. First, storage duration is increasing as well. The same thing happened in China, like spam. It also the duration has grown from 2.1 hours in 2021 to 2.6 hours in 2025, and also it's expected to continue increasing towards 2030. And CNESA, according to CNESA projection, the duration will increase to nearly 3.5 hours by the end of 2030. Next, please. Second, the market is shifting from skill-driven growth to quality-driven growth. Although the growth rates may gradually slow, annual installations are expected to remain at a very high level. According to CNESA forecast, China's cumulative new energy storage capacity will continue to grow rapidly towards to 2030. Will reach to nearly 370 gigawatts and 450 gigawatts into different scenarios. And next, please. To conclude, I would like to leave you with 3 key messages. First, the rapid expansion of renewable energy has created tremendous opportunities for storage. Second, China's energy storage market is shifting from policy. And the second, China's energy storage market is shifting from policy-driven to market-driven growth. Going forward, market rules will increasingly determine project revenues, especially for standalone energy storage. Revenue opportunities vary significantly across different provinces and even between different grid locations within the same province, depending on the local market design and power system conditions. The third one is innovation in market mechanisms. Business models and also carbon accounting will define the next stage of the industry development. And some numbers and our outcomes were supported by the NRD and the research of next, please. Some numbers and also some outcomes were supported by the National Key N&D Program of China. Next, please. And this concludes my presentation. Today, CNESA has more than 800 member companies covering the entire energy storage value chain. I hope today's presentation has helped our Spanish stakeholders better understand China's energy storage market and will create more opportunities for cooperation between our members and the partners in Spain. I would also like to warmly invite all of you to ESIE, the Energy Storage International Conference and Expo, which will be held in Beijing from March 17 to 19 next year. It's a global platform that brings together policymakers, industry leaders, researchers, and innovators from the world. We sincerely hope to welcome you to Beijing next year and explore new opportunities for our cooperation together. Next, please. Finally, CNESA's annual white papers provide insights into China's energy storage market. We would like to share more information with you after this in this session. Thank you very much.
Thank you, Yue, for your presentation.
Thank you.
We'll go to our next speaker, Mr. David Sanchez, Head of Energy Storage in Longhi, Europe. He's going to speak about product innovations.
Hello, everyone.
Hello, David. So the presentation will be about product innovation, mainstream PCS concept, and Longhi best COE in Europe. David, you can
thank you so very much. Thank you, Francisco. I appreciate it. Can everyone see my screen?
We can see your sharing. We cannot see it's loading the presentation, I think. Right now, okay, now we can see.
Now it is? Okay, thank you very much. So first off, let me please introduce myself. I'm David Sanchez. I'm the head of storage for Longhi in Europe. Previously, I was general manager of Longhi Technologies in Spain. Okay, so actually Longhi, who everybody knows, is a very big player in the renewable energies. one of the biggest Chinese players in the renewable energies, and actually with big synergies and business and collaboration and deployment in Spain. Okay, so Spain is a very key market when it comes to the deployment of all kind of renewable energies, from PV to inverters to storage. And this is where we see a big synergy and collaboration between both China and Spain. So in the case of LONGi, as I was mentioning, so everybody knows LONGi very well, is a top player in the renewable energy sector. What is very interesting is that LONGi is the only supplier that can actually supply us of today the three main technologies in terms of our way for a green transition. So solar, storage, and hydrogen, right? Which we call the stable triangle, which speaks volume about the kind of company that LONGi is and the kind of commitment and engagement with both European and Spanish market in terms of helping and working alongside this green transition that Spain and Europe are pushing through. In terms of the history of LONGi with storage, so let me please remind that LONGi has been present in the storage business through Botisech since 2013. So the time between 2013 and 2020 was a time of a lot of technology development, a lot of patent development, a lot of building the grounds for a very solid and technological company. So everything come to fruition after 2023, especially in 2024, as you can see, where LONGi Botisech was actually recognized as not only tier one for the best market, but top 3 ESS integration by InfoLink, right? So this was a massive milestone for our company, and again, a massive step forward in terms of our presence in the market. Then, late 2025 is when LONGi formally acquired Botisech, and through 25 and 26 is when LONGi is actually developing new innovation and bringing these new innovations to the market, just with one target, lowering LCOS and facilitating the green transition, and especially the challenging moment that we are now facing with PV industry, where actually we need a very rapid deployment on storage across Europe and across Spain. In terms of some numbers, LONGi has delivered more than 13 gigawatt hours in 13 years. Right now has an existing capacity of production of 31 gigawatt hour. But the very interesting thing is that we expect more than 100 gigawatt hour capacity for 2028, which again speaks very strongly on the commitment that LONGi has also for the storage business, which again, from utility to residential through CNI solutions. As I mentioned before, so LONGi is not only recognized as tier one for the best industry, but actually was ranked from InfoLink in H125 as the fifth biggest supplier for DC storage solutions, okay? Which again talks massively about the level of engagement and the level of deployment that LONGi is ready to do in terms of the storage industry. LONGi, we rebranded our new best innovation to only one, LONGi One, for one reason. It actually is one system. We have full supply chain and integration from cell to turnkey solution deployed on site. We have one platform, one intelligent software platform, and we have one responsibility. So as I said, everything is in-house, and not only LONGi can deliver a best solution, but also can deliver the cutting edge technology in PV module, which is the back contact and the high monite technology, right? So very rare to find and very unique to find in this market, one company that can actually deliver both high-end technology and innovations. In terms of the product family and the new innovations that we are bringing to the market, which again, with only one target, lowering LCOS and facilitating the green transition, and especially the difficult moment that the PV industry is going through, where we need not only ancillary service to the grid, but also all the customers, all the IPPs, they actually need to monetize the PV asset, hybridizing and making some arbitrage, right? So we are bringing these innovations to the market that we call One Matrix and One Bank. Both solutions are actually based on 6.25 megawatt hour container with just a couple of nuances. In the case of One Matrix, we are talking about a separate solution for the PCS and the transformer. In the case of one bank, we have embedded PCS inside the container. So both solutions are actually based on string PCS solution, and not for no reason, because we believe that the only and the most efficient way to actually decrease LCOS and facilitate the transition is actually to bet on the most efficient PCS system, which is the string PCS, which I will detail right now. Looking into One Bank 2.0, which is, as I said, our newly 6.25 megawatt hour solution in DC and AC. Okay, not only the RT can reach up to 93%, not only the string PCS concept delivers better protection through the R-fault detection and through a superior ground and thermal insulation, but also when it comes to delivery, when it comes to end accountability, right? So we know very well that through the last years, the solar PV string inverters took over the European market, and this is going to happen also with the storage industry, and it's not for no reason, right? So in the end, it's just about modularity brings more availability. More availability delivers better results and better RIR to our customers, right? So this is happening exactly the same path in the storage industry, where the solutions based on string PCS will actually deliver a better result, better performance, and lower LCOEs. This is how our One Bank innovative solution looks like. So basically, you can see left-hand side, all the battery packs. It's actually a 416 cells in series and an 8 rack in parallel. Right-hand side, you can see all the 4 PCS that are included in the container. As I said, this is a 6.25 megawatt hour AC container, right? With all the savings in terms of civil works and BOS that it implies, not only in performance. And one very important flagship from LONGi is safety. So we are very proud that in more than 13 gigawatt hours delivered, we have a 0 thermal runaway record, right? So, which is very impressive, and it's actually a key part of the bankability of the product, because everything in this best industry goes around financial bankability, product, and safety, right? In order to get the right financing and the right approach and financial model for the best plans. So here, LONGi has invested massively, a lot of resources and R&D with our own patents, in a way that we have what we call ICCS, Intelligent Cell Control System, which will control all the battery packs in terms of current, short circuit current, voltage, and resistance. All this will lead to our algorithm being able to forecast any potential issues with several months in advance. As I said, this is something that is actually certified by a third party, and is one of the flagships of LONGi: safety and 0 thermal runaway in more than 13 years. And for this, it's very important to remember that LONGi actually comes from the innovative. So all the storage products come from the automotive industry, right? Which has very, very high standards in terms of safety and performance. And we actually have a 3-level BMS system, right? With cell level monitoring, module level monitoring, and cluster level monitoring. As I said, this is actually of the essence for our own system, in order to guarantee and to have the 0 thermal runaway and the safety forecast that we are actually quite proud of. In terms of the PCS, so as I said, so the very same way that the solar market gravitated from central inverters to a massive adoption of string inverter, this will happen very similarly in the best storage industry, which again is an industry that is still under the maturing process. But for sure, one of the key part of the maturing process is customer looking for lower LCOEs. And the lower LCOEs can be achieved through a higher availability. And this can only be achieved with string PCS. But not only this, in the end, you have the barrel effect and circulating current that is limited. You have a lower THD behavior, you will have a higher DC insulation, you will have a better R-fault protection, right? So there's all the indicators and all the experience that we have in this Europe market, very mature market, tell us that the string PCS is going to be the next big thing, the next big innovation, and those players who will adopt this will definitely be able to supply with a more performance solution to all the players in Europe. And as I said, it's not for no reason. So when you have a string PCS, you have full modularity compared to a centralized PCS. You have full insulation, limited in the case of central PCS. You have way higher operational availability, right? So more than 99% in most of the cases. When you have any issue and you lose the PCS, you lose 230 kilowatt. You don't lose more than 1 mega up to 5 megas, right? As I said, the system insulation works with a higher insulation level, normally more than 20K ohm. In the case of centralized inverters, our PCS is less than that. Also R4 detention and monitoring, no DC cable. And when it comes to commissioning, everything is in broadcast mode, everything is faster, everything is easier, right? So for sure, all the indications tell us that the next big innovation in the storage market is going to be containers based on string PCS, and LONGi is already on that path. In terms of savings, so you will have, using LONGi solution, using a solution based on string PCS, you will have savings on project design, on procurement, on production, on delivery, civil construction and BOS, cable laying, and subsystem debugging, right? So everything will make the system cheaper, more competitive, and with a higher IRR. And actually looking into specific scenarios, specific cases, we see how in terms of system efficiency, in terms of safety performance, operational availability, which will be the key factor and the factor with the highest weight in terms of the performance and the rentability and profitability of the plant. Savings there, delivery, and also liability guarantee, right? So roughly in an average project, you will have a massive saving, which will turn in really critical when we're talking about 20 years or 25 years lifetime with one cycle or more per day. And one important thing, one very critical thing about LONGi. LONGi is, as I said, one of the biggest players in the market, one of the biggest Chinese players in the market. And we have a global footprint. So not only we have production factories all over the globe, but we also have a very strong presence from the logistic and sales point of view, which allow us to actually deploy very rapidly our strategy in Europe. What is our strategy in Europe? It is the build up, which again, we have already a big progress and a very, very good progress on that regard, of what we call the Center of Excellence, the COEs all across Europe. So this Center of Excellence will be a hub for a local technical competency and very focused on local support to our local customers, from Spain to Germany, from France to Italy, from the UK. This is part of our strategy. We believe that this is differential because apart from bankability and performance, what customers need to be able to feel secure, safe, and to mature alongside the market is for sure the local presence, which again, LONGi can rapidly deploy the resources due to the local presence already existing. A key thing when it comes to this COE, for sure, is the deployment of LTCA, which is a critical part of any best project, not only from the operational point of view, but also from the financial point of view, right? So we understand this. We are already kicking off several projects, and we have already our existing resources locally, as I said, from Spain to Italy, from France, from Romania to the UK. And finally, some references that LONGi already has in Europe. In the case of Italy, 50 megawatt hour in Montalto, 1 hour of Rome is a very challenging project, given the support to the grid and given the closeness to the sea. Despite this, the farm is actually performing nice and beautifully. Same in Sweden, where we have this hybrid plant with the wind project. This project that we are delivering in Ukraine, and finally this project in Finland and Romania. And also finally, let me please highlight that LONGi is also investing massively in other markets like Australia market or the US market. And I would be happy if anyone is interested. I would be happy to offline describe and go through the details to the US and Australia market. And this is a little bit from my side. So as I said, thank you so very much for the opportunity to represent LONGi and to explain a little bit what we're doing in Europe and what is our level of innovation. Thank you so very much.
Thank you, David, for your presentation. Luis, yes. Hi,
I just wanted to thank all the presenters that have already made the presentation so far and encourage the next presenter to keep the same level. Thank you.
Thank you, Luis. So we move forward to the next speaker, Dr. Changchun Liu, Associate Researcher of the Institute of Engineering, Thermophysics, Chinese Academy of Science.
Okay. Can you see my slides?
We are seeing your screen, not your slides. Right now we are seeing the Teams page.
So how about now?
Still seeing the same.
So how about now? Can you see my slides?
Not yet. Right now, I still see the Teams window.
Okay, how about now?
Okay, yes.
Okay.
It's working. Thank you.
Hello everyone. This is my research about underwater isobaric compressed air energy storages. I'm Changchun Liu from the Institute of Engineering Thermophysics, Chinese Academy of Science. Today I will give you an introduction about the research progress of our research on underwater isobaric compressed air energy storage system. I will introduce our research in these 5 aspects. So the first is the introduction. Compressed air energy storage is one of the main promising technology of energy storage, which includes charging process to compress air and then storage the air in a storage tank or underground caverns. And during the discharge process, it will release the compressed air in a turbine and to produce electricity. This is the conventional compressed air energy storage system. It has many advantages. For example, high power ratings can be more than 100 megawatt, low cost, long lifetime, unlimited storage duration. It can be longer than 4 to 10 hours. This is a report from the IEA, which compares the available energy storage technologies like batteries and compressed energy storage system, which concludes the compressed energy storage system offers the lowest capital installation cost and levelized cost storage cost. And they also prediction about the 2030 the global compressed energy storage system installed capacity will be reached 60 gigawatt hours per year, covering 37.5% of total energy in storage capacity. And this is the state of our conventional compressed air energy storage system. You can see the commercial compressed air energy storage system plants were constructed in many countries. However, there are some challenges of conventional compressed air energy storage system. For example, it will need little gas during the discharge process, and their efficiency is low, as about 40 to 50%, and it will release some carbon dioxide during the discharge process. So our overall strategy is for advanced compressed energy storage system. At first is to use high efficiency compression and expansion, heat transfer and storage at supercritical state to improve efficiency. And second is use liquid and high pressure storage to avoid block storage of cavern. Third is recycling the compression heat to avoid fossil fuels. The challenge is about relying on black carbon, relying on fossil fuels, and low efficiency. So our solution is to recycle the compression heat, high pressure storage, and improve efficiency by advanced compressed energy storage systems. For example, you can see about this for conventional compressed energy storage system. During the compression heat is released, and during the discharge process, the natural gas will required to improve the temperature of the air and then to expand there. But for advanced compressed energy storage system, we use the heat storage to reuse their compression heat, and there is low need for natural gas. As for underwater compressed energy storage system, we use underwater flexible airbags or open rig cabins to store compressed energy storage. So during the charging process and discharging process, the pressure in the storage air storage cabins are constant, so the compressor and the turbine can operate at all the time. So the advantage of the advanced compressed energy storage for our setting, low fossil fuels, high efficiency. So there are three fundamental scientific issues about this compressed energy storage system. The first one is the process coupling on the energy transmission mechanism, flow field of compressors and expanders. And the third is the flow and heat transfer and storage in confined space. So our technology about to develop technology is about three parts. Technology one is the system optimization and design, and technology two is about for 3D design about compressor and expanders, and technology three is the compact heat transfer and storage with high efficiency. This is introduction of our 1 megawatt underwater compressed energy storage system experiment system. This is with two eddy current thermometer for the turbine power output to the eddy current thermometer is for fast, sensitive to speed control during the startup. And hydraulic thermometer is for high capacity but slower response to shear load. And this is the parameters that we used during the experiment. is meaning about the temperature, pressure, volume flow, mass flow, and power. And we use the mass flow and astronomical efficiency and shift power to evaluate this system. And this is the experiment result are about the discharge process. As you can see, the temperature and the pressure during the discharge process is constantly. And this is the airbag storage. And this is during the discharge process, and the speed and vibration of the compressor with our efficiency control, the speed overshot is within 14 RPM, and the flexion is less than 3 RPM after stabilization. And the force startup is about 5 minutes. And this is the net temperature and pressure about our expanded turbines. For this 1 megawatt underwater compressed energy storage, the turbine shift power reaches 1.3 megawatt under the inlet condition of 6.3 megapar and 115 degrees Celsius, and the isentropic efficiency of the turbine reaches 89%. And this is the video of the 1 megawatt underwater compressed energy storage system discharge process. For the underwater compressed energy storage system, we when it compete with the isochoric compressed energy storage system, the efficiency can be increased about 1 to 5%, and the density is increased from 3.5 to 7.3. This is our team. That's all. Thank you for your attention.
Thank you very much, Leo, for your presentation. This was the last presentation of this session, so we can leave a few minutes right now for question and answer. If you have some doubts or you want to ask some questions to our speakers, please open your mic and ask directly, or you can use the virtual hand. Okay, so yeah, I understand there are no questions. If you have further question later on, you can email us, and we will do our best to give you an answer, speaking and talking to our speakers. So thank you all for participating. Thank you all to all the speakers for their participation, and thank you also to CNESA and the Chinese Academy of Science to collaborate with BatteryPlat in the organization of this webinar. The recording will be available on our website, and we will make sure to pass it forward to the Chinese organizations so they can also share the recording with their members and associates.
Okay, Francesco, I also want to thank to all the speakers and participants for these insightful presentations, because today's presentations have shown both the scale of the opportunities and the diversity of technologies that will shape the future of energy storage, from advanced battery solutions to emerging long duration storage concepts. So on behalf of BatteryPlat, thank you and have a wonderful day.
Thank you, Francesco. Thank you, Luis. This event creates a platform for our members, the industry colleagues, for the collaboration between China and Spanish energy storage market. We wish that we can continue our partnership and host various activities to promote the collaboration. Thank you so much.
Thank you.
Thank you. Bye-bye.
Bye.
Thank you. Bye-bye.